Hello, Algebra 2 folks, and welcome to Solving Exponential Equations. Finally, the reason we're learning about exponents and logs. All right, so you're going to need your notes, a calculator, and a pencil, and we will get started. So before we solve exponential equations, let's talk about the things we need to know. So you need to know the properties of exponents or the rules of exponents from Chapter 6. You need to know how to change to log form. Okay, remember log form helps us isolate the exponent. And that's what we'll need to be able to do to solve exponential equations. So 4 squared equals 16 is the same as the log base 4 of 16, which is equal to 2. Remember 2 is the exponent. Okay. E to the fifth is equal to 148.4. That's the same as log base E of 148.4, which is equal to 5. And remember, log base E is the same thing as writing ln. So it's preferable that you write ln of 148.4 is equal to 5. The other thing you need to know is the change of base formula. The change of base formula says log base A of B is equal to log base 10 of B over log base 10 of A. Remember, because our calculator has base 10, we have to use the change of base formula for any other base besides 10 and E, because the calculator also has ln, or log base E. All right, so there are two different types of exponential equations that we need to look out for. One is that you might see exponents on both sides. So if you see exponents on both sides, what we need to do is we need to get our bases to be the same. So that yellow sheet is going to come handy when we need to get the bases to be the same. All right? Notice that here's a 2 as a base, here's a 32. I can't make the 2 become a 32, but I can make the 32 become a 2. Remember, you always have to think smaller. So the same thing would be 2 to the fifth is the same thing as 32. Okay, so we want to get the bases to be the same if we have bases on both sides. Then the other type of exponential equation that we're going to run into today is exponents only on one side. So here's an exponent on one side, no exponent on this side. And what we can do with these is we can convert these ones to log form. Okay? So when you have bases on both sides, we won't be able to convert to log form. We're going to get them bases to be the same. And if we have a base on one side or an exponent on one side, then we can convert it to log form and isolate that exponent. So those are the two types of equations you're going to see today. Okay, so the first thing we're going to do is exponents on both sides. Think about things, making things equal. So here's a base, 3x, the base is 3, and that's equal to 3 to the fifth, the base is 3. And if the bases are exactly the same, we can take the exponents and set them equal. So we can say x equals 5. Okay? But then what happens when the bases aren't the same? Well, when the bases aren't the same, we have to be able to get the bases to be the same. So this is where your yellow sheet is going to come in handy. So you're looking for a column that has a 9 and a 27. And if you look, it's in the cubed column. It's in, in the row, the 3, we're looking for the row, not the column, excuse me. So when you look for the 9 and the 27, you're going to look across in the same row, and you're going to see they all go back to a base of 3. So 9 is the same thing as saying 3 squared, okay? So I'm going to change that 9 into 3 squared. And I'm going to bring down the 2x with it. If I look at the 27, you're going to see that that's in the same row. Row goes horizontally, folks. That's the same row as the 9, which is also in the same row as the 3. But this one happens to not be in the squared column, but in the cubed column, because 27 is the same thing as 3 cubed. Okay, so we're always trying to get back to that base on the left-hand side, 1 through 10. We're always trying to use those to help us with these kind of problems. So 27 is the same thing as 3 cubed. And then I'm going to bring down the x minus 1. So now that the bases are the same, I can make the exponents equal. But before I do that, I have a power to a power. And what do you do with power to powers? You multiply them. So this becomes 3 to the 4x, which is equal to 3 to the 3x minus 3, because you're going to use the distributive property and multiply that 3 by both of those things. Now when the bases are the same, we can go ahead and take the exponents and set them equal. So 4x equals 3x minus 3. Subtract 3x from both sides, and I get x equals negative 3. All right, and then I could plug that into my calculator and verify that they did check out to equal each other. All right, now let's talk about exponents on one side. Now if we have exponents on one side, what we want to do is isolate the base and change into log form. Okay, so here's my base, there's my exponent. I want to isolate that, get it alone so I can get it into log form. So I'm going to add 1 to both sides. That's 2 to the power of x equals 7. And then I'm going to write this in log form. And so log form would say log base 2 of 7 equals x. I isolated that exponent. And now that I've isolated that exponent, I can use the change of base formula. Remember, the change of base formula is log base 10 of 7 over log base 10 of 2. I type that in my calculator, making sure that I close those parentheses around the 7 and the 2, and I should get approximately 2.81. Okay, then if you take 2 to the power of 2.81 and subtract 1, you should get approximately 6. Okay, and I kind of made a mistake there, so I'll go ahead and erase that out of the way. So 2 to the power of 2.81, subtract 1 should give you roughly 6. Okay, I'm going to solve for x again. Again, I need to get that exponent and base alone. So I'm going to subtract the 5 from both sides. I get 10 to the power of x is equal to 55. Now that I have one base, remember I have to only have one base in order to be able to convert this to log form. So now I'm going to say log base 10 of 55 is equal to x, isolating that exponent. Okay, and now my calculator does log base 10, so I don't need to do a change base formula here. I can just type that into my calculator as is, and I'm going to get approximately 1.74 is equal to x. And now you can check that by putting 10 to the power of 1.74 plus 5 into your calculator, and you should get roughly 60. All right, let's try another one. This time I have 4e to the 2x equals 5, and I need to get the base and exponent alone. This 4 is not part of the base. What's the base? The base is e. The exponent is 2x. So what I need to do is I need to divide by 4 first. So I'm going to have e to the 2x is equal to 5 over 4. And now that I have this base isolated, I can go ahead and write it in log form. Log base e of 5 over 4 is equal to 2x. And remember, log base e is the same thing as ln. So we are going to use the ln button in my calculator and divide that baby by 2 to get x alone. And x is going to be roughly 0.11. Now you can plug that back into your calculator for a quick check. You can type in 4e and in parentheses 2 times 0.11, and that should give you roughly 5. All right, let's try one more. All right, so I have 3e to the power of x plus 1 is equal to 85. My base is e, my exponent is x, so ultimately I need to get that isolated and alone. So the first thing I'm going to do is I'm going to subtract 1 from both sides. So I get 3e to the x is equal to 84. And then I'm going to go ahead and isolate my base and exponent by dividing by 3. And e to the x is the same thing as 28, because 84 divided by 3 is 28. And now I'll rewrite this in log form. Log base e of 28 is equal to x. Log base e is the same as ln. ln of 28 is equal to x. And that will equal approximately 3.33. And again, if you type that into your calculator, 3 times e to the 3.33 plus 1, you should get approximately 85. All right, that's all that I have for you today, folks. We're going to practice this, and then we're going to go ahead and learn about solving log equations. So equations that have logs in them, that's to come. All right, thanks for taking good notes, and we'll see you tomorrow.